In this video, I will discuss find the complex exponential Fourier series of the waveform shown below. Determine complex exponential Fourier series quotient. Complex exponential Fourier series quotient. Come on. Plot magnitude spectrum. Plot the magnitude spectrum. And determine Fourier series quotient. Fourier series quotients. Quotients from complex exponential Fourier series quotient. Here the waveform is like that. This is the waveform x of t. Minus 1, 1, 2, 3, minus 2, minus 3, 1, 0. This is the waveform shown in the figure. Here, first find out the time period of the waveform. The time period of the waveform is here. This one is t naught. This one is t naught plus t. Consider one cycle of that periodic waveform. This one is t naught. This one is t naught plus t naught. T naught is equal to minus 1. T naught plus T naught is equal to plus 1. Here T naught is equal to minus 1. T naught is equal to minus 1 plus 1 plus T naught is equal to 1. Therefore, T naught is equal to 1 plus 1 is 2. Time period of the waveform is 2. Here, this one is even symmetry. Even symmetry. Even symmetry means x of t is x of minus 2. Both are same. This one is a positive time values. This one is negative time values. X of t is x of minus t. Therefore, an is there. An value is find out to be determined. A naught value is also to be determined. Bn is equal to 0. This one is even symmetry waveform. Consider one time period interval. This one is x of t, t minus 1, 1. Here the value is here is 1. Coordinates of this one is here x-axis is 0, 0, and the y-axis value is from this point to this point, the value is 1. Here, x-axis value is -1, comma 0. Here, 1, comma 2. The coordinates are -1, comma 0 and 0, comma 1, -1 less than or equal to t less than or equal to 0. And another coordinates are 0, comma 1 and 1, comma 0. 0 less than or equal to t less than or equal to 1. Therefore, first of all, you have to find out the equation in that interval -1, comma 0, 0, comma 1, x1, y1, x2, y2. Y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. Here y minus 0, y2 minus y1 minus 0, x2 minus x1 0, minus or minus plus 1, x minus, that is x minus of minus and x plus 1. That is equal to y is equal to x plus 1 in the interval. -1 less than or equal to t less than or equal to 0. Y means y-axis means x of t function y-axis. X-axis means time t plus 1. -1 less than or equal to t less than or equal to 0. And similarly, consider this interval 0, comma 1, 1, comma 0, 0 less than t less than or equal to 1, x1, y1, x2, y2. Y minus y1, y2 minus y1 by x2 minus x1, that is x minus x1. Y minus 1, y2 is 0, minus y1 means 1, x2 is 1, x minus 1 is 0, x minus x1 is 0. That is equal to y minus 1, minus 1 by plus 1 is minus 1 into x. Here y-axis is reference x of t. Here minus t. X axis means time axis. Minus bring this side, that is plus 1. That is equal to 1 minus t. X of t is 1 minus t. In the interval 0 less than or equal to t less than or equal to 1. Next, to find out exponential Fourier series, complex exponential Fourier series question. X of t is equal to, we know that sigma n is equal to minus n to plus n t Cn e power j n omega naught t. From that expression, you have to calculate Cn value. Cn is equal to 1 by time period small t naught plus capital T naught sub t e power minus j n omega naught t dt. Here the small t naught, you consider this one waveform. This one is -1, this one is +1. This one is small t naught plus capital T naught. We know that t naught is equal to 2, already determined at the beginning. 1 by 2 minus 1 to plus 1 sub t e power minus j n omega naught t. That is, split this into, this interval is split into two intervals, minus 1 to 0 and 0 to 1. -1 to 0 x of t e power minus j n omega naught t dt plus 0 to 1 x of t e power minus a n omega naught t dt. That is equal to 1 by 2. In the interval -1 to 0, -1 to 0, x of t is 1 plus 2. X of t is 1 plus t e power minus a n omega naught t dt, and interval -1 to 0 plus 0 to 1 x of t is 0 to 1 x of t is 1 minus t. X of t is 1 minus t e power minus a n omega naught t dt. That is equal to 1 by 2 integral -1 to 0 e power minus a n omega naught t dt split into two intervals, and -1 to 0 t into e power minus a n omega naught t dt plus 0 to 1 0 to 1 e power minus a n omega naught t dt minus here minus 0 to 1 t into e power minus a n omega naught t dt. This is the expansion that is equal to here 1 by 2 that is equal to 1 by 2 integral of e power minus a n omega naught t dt is e power minus a n omega naught t by minus j n omega naught minus a n omega naught. Limits are -1 to 0. This one is use some number bracket. And plus P into use the UV formula P into e power minus a n omega naught t by j n omega naught minus differentiation of t dt by dt, that is 1 e power minus j n omega naught t by minus j n omega naught minus j n omega naught. Interval is -1 to 0. Limits are -1 to 0. Next, third one is e power minus a n omega naught t dt, that is e power minus j n omega naught t by minus j n omega naught that is equal to 0 to 1 minus t into e power minus a n omega naught t by minus j n omega naught minus dt by dt is 1 e power minus j n omega naught t by minus j n omega naught minus j n omega naught that is equal to interval is 0 to 1 and finally close bracket. That is equal to 1 by 2. Substitute 0. E power 0 is 0. E power 0 is 1. 1 by minus j n omega naught minus j n omega naught. Here minus into minus plus for the lower limit minus. Here minus is there. E power here t is equal to minus 1. Minus into minus plus j n omega naught by j n omega naught. Here this is the substitute 0 for limit 0 into something 0 and j into here 0 minus j into j square minus into minus plus j into j square minus into minus plus minus into minus plus by 1 by n square omega naught square. Substitute lower limit here t is minus 1 minus into minus plus, but for lower limit we use minus of that one minus e power minus 1 is substituted here minus into minus plus e power j n omega naught by e power j n omega naught by n square. This one is plus. These two limits are substituted. Next, coming to this one, plus e power minus a n omega naught t. T is 1, e power minus a n omega. E power minus a n omega naught. Here minus sign is there. Minus j n omega naught. Next to 0 limit, for a 0 limit, e power 0 is 1, minus of minus plus 1 by j n omega. This is also completed. Coming to this one is minus. Upper limit is 1 into e power minus j n omega naught by minus j n omega naught for t is equal to upper limit is 1, lower limit is 0, minus e power 0, e power 1 for this one, e power minus j n omega naught, j into j square minus 1 minus into minus plus minus into minus plus n square omega naught square. Substitute lower limit. 0 is substituting, 0 is there here, minus into minus plus for lower limit. This one is minus into minus plus. Minus into minus plus, but j into j square minus 1. Finally, we got minus 1. N square. That is equal to 1 by 2 minus 1 by j n omega naught plus e power j n omega naught by j n omega naught plus 1 by n square omega naught square minus e power j n omega naught by n square omega naught square e power minus j n omega naught by j n omega naught plus 1 by j n omega naught. Here minus into minus plus e power minus j n omega naught by j n omega naught minus into minus minus into plus minus e power minus j n omega naught by n square omega naught square minus into minus plus 1 by n square omega naught square. For this one 0 minus 1 plus 1 by n square minus square here minus into minus here only 0 is forget minus 1 minus into minus plus t is equal to minus 1 is not substituted here. T is equal to for t is equal to 0 0 here minus into minus plus for t is equal to 0 this one is n square omega square j square is equal to minus 1 minus plus minus into minus plus. Okay, for n is equal to minus 1 this one is a minus into minus plus minus into that is minus t is equal to minus 1 means minus e power j n omega naught by n square omega naught plus one more term is missing here. This one is minus 1 minus into minus plus into minus into minus plus j square minus 1 minus plus minus 1 is substituted here e power j n omega naught t by n square omega naught square. Here for lower limit minus of minus plus here j square is minus into plus minus that is here finally we got minus sign. One more term is missed here that is 1 by n square minus j n omega naught by n square omega square. Here one more term is there that is minus e power j n omega naught t by n square omega naught square. Minus j minus 1 by j n omega naught plus 1 by j n by omega naught is cancelled. Here plus j n omega naught by j n omega naught. Here minus j n omega naught t is not there by n square omega naught. This is cancelled. These two are cancelled. Here these two are present and also e power minus j n omega naught by j n omega naught minus e power minus j n omega naught by j n omega naught. These two are cancelled. Finally, the remaining terms are 1 by 2, 1 by n square omega naught square plus 1 by n square omega naught square, 2 by n square omega naught square. Here minus e power j n omega naught by n square omega naught square minus e power minus j n omega naught by n square omega naught square. That is equal to 1 by 2 by n square omega naught square minus 1 by n square omega naught square e power that is e power j n omega naught plus e power minus j n omega naught. Here 2 cancel 1 by n square omega naught square. 1 by 2 is multiplied here 1 by n square omega naught square e power j n omega naught plus e power j n omega naught by 2. This is 1 by n square omega naught square 1 minus e power j n omega naught plus e power minus j omega naught. That is cos n omega naught. Therefore, Cn is equal to this one is simplified in n square omega naught square 1 minus cos n omega naught is 2 pi by 1 by n square omega naught square 1 minus cos 2n pi by t naught is 2. That is Cn is equal to 1 by n square omega naught square 1 minus cos n pi minus cos n pi, because n not equal to 0. N not equal to 0. For n is equal to 0, Cn is infinity. You have to find out C0. N is equal to 0 means C is equal to 0. For magnitude function, mod Cn is equal to omega naught is 2 pi by t naught whole square 1 minus cos n pi is minus 1 whole power n. That is equal to 1 by mod n square t naught is 2. The t naught is 2. 2 cancel. T naught value is 2 cancel. That is equal to pi n square pi square 1 minus 1 whole power n. Here we use modulus. Here we use modulus, and n is also square value for even for plus values and minus values. Actually we will get a positive value. For n is equal to consider odd values plus or minus 1, plus or minus 3, plus or minus 5. That is for odd values. Therefore, mod Cn for odd values, suppose n is equal to 1, minus 1 whole power 1 is minus 1, minus into minus plus. That is for odd values 2 by n square pi square. Modulus of 2 by n square pi square for odd values of n. For even values of n, n is equal to 0 is not considered. Plus or minus 2, plus or minus 4, plus or minus 6. Therefore, Cn is equal to 1 by n square pi square 1 minus 1 whole power whole square means 1 that is 1. 0 by mod 0 by something is 0. For even values, the Cn is 0. For odd values, suppose n is equal to 1. Mod C1 is equal to mod C minus 1. N is equal to plus or minus 1. N is equal to plus or minus 1. The value is for n is equal to plus or minus 1. In both the cases, square is there. 2 pi plus or minus 1 whole square, that is 1. That is 2 pi square. N is equal to 2. C is equal to 2. C minus 2. That is equal to 2 pi 2 square plus or minus 2 whole square, that is equal to 4. 4 pi square. That is equal to n is equal to 2. The value is 1 by 2 pi square. Not 2 here. Odd values. C3. C minus 3. That is 2 pi 9 pi square. C5. C minus 5 is equal to 2 by 25 pi square. N is equal plus or minus 1. For odd values, the value is 2 by mod 2 by n square pi square. For even values, the value is 0. Find out 0. Cn is equal to, we know that 1 by t naught minus 1 to 1 sub t e power minus a n omega naught t at. We know that t naught is 1 by 2. Minus 1 to 0 x of t is 1 plus t e power minus a n omega naught t dt plus 0 to 1 x of t is 1 minus t e power minus a n omega naught t dt. For t is equal to 0, n is equal to 0. C now, that is equal n is equal to 0. 1 by 2 minus 1 to 0, 1 plus t e power 0 is 1 plus 0 to 1, 1 minus t. That is equal to 1 by 2. Integral of 1 dt is t, 0 minus 1. Integral of t is t square by 2 minus 1 0. Integral of 1 dt is t 1 0 minus t square by 2 1 0. Substituted here, 0 is substituted, minus of minus plus 1. Here minus 1 by 2 plus 1 minus 1 by 2. That is equal to 1 by 2, 2 minus 1. Minus 1 by 2 minus 1 by 2 is minus 1. That is equal to finally 1 by 2. C naught value is 1 by 2. For even values, zeros. Cn is 0 for even values. Plus or minus 2, plus or minus 4, and so on. Cn is equal to 1 2 pi n square pi square for odd values. Plus or minus 1, plus or minus 3, plus or minus 5, and so on. mod Cn, this is n is equal to 0, C0 value is 1 by 2. For n is equal to 1 and minus 1, n is equal to 1 and minus 1, the value is 2 pi square. N is equal to 2, n is equal to minus 2, the value is 3, the value is 0. N is equal to 3 and n is equal to minus 3, the value is 2 by 9 pi square. Here also 2 by 9 pi square. Here 2 by pi square. So 4, the value is 0. Minus 4, the value is 0. 5, 2 by 25 pi square. Minus 5, 2 by 25. This is the spectrum of Cn. Cn is equal to An minus Jbn by 2. C minus n is equal to An plus Jbn by 2. Cn is equal to 1 by n square pi square 1 minus cos n pi. C minus n is equal to 1 pi minus n whole square. N is replaced with minus n. 1 minus cos minus n pi. That is equal to 1 by n square pi square 1 minus cos. This is the even symmetry waveform. Therefore, Cn is equal to minus Cn. Cn is equal to C minus n. Cn is equal to C minus n. Both are equal. Therefore, 2Cn is equal to An minus Jbn. 2Cn is equal to C minus n is equal to An plus Jbn. 2Cn is equal to An minus Jbn. 2C minus n is equal to An plus Jbn. These two equations are added. 2 into Cn plus C minus n. These two are cancelled. 2An. Therefore, An is equal to Cn plus C minus n. Subtract these two equations. These two are cancelled. 2 into Cn minus C minus n is equal to minus 2j. Cn is equal to C minus n. Therefore, Cn minus Cn minus 2j. Therefore, Bn is equal to 0. An is equal to Cn plus Cn because Cn is equal to C minus n. 2Cn. 2Cn. 2 into Cn is equal to 1 by n square s square 1 minus cos n pi. A naught or C naught is equal to 1 by 2. An is equal to 2 by n square s square 1 minus cos n pi. Bn is equal to the Fourier series questions from exponential complex exponential Fourier series question. Cn.